Hello. So, we were discussing about several aspects of spatial informatics. Rather, if you recollect that last class we started with we were discussing about spatial query processing, or how we can process queries into the things. Like any information system, the query processing plays an important role, right. So, as we have discussed, it is not only retrieving, I can input data and manipulate data and type of things. So, end of the day, for the end user or even that other end systems, this SQL plays an important role, right. So, what I believe that you have some fairly good knowledge on normal databases, relational databases and SQL. So, we will build up on that, right. So, the obvious query will come that why, if there is already a database system and SQL is in place, why you require a spatial database, a special SQL for that matter, right. So, why we require a special consideration for SQL for spatial data, that we will try to see over looking at different type of examples, different type of approaches and type of things, right. So, we should again keep in mind the spatial databases are pretty large in nature and they have both computationally intensive and data intensive, right. In number of cases, I may not be able to pull the whole data in the main memory to process the queries, right. I need to have some other mechanism to do that, right. And with this context, let us see a few example scenarios. Last class also we have seen some of the things. We will be primarily referring to that standard book of Professor Shashi Shekhar and Professor Shekhar for this purpose also, right. So, SQL, so if we have a general, very generally, it is a standard query processing for any relational database is known to us. It supports logical data concept like relationals, primary key, foreign key and all those things, supported by a major bunch of vendors from Oracle to IBM to SQL Server to Sybase to MySQL to any open source SQL, any open source database engines. So, it is a de facto language for any database. There are several versions which are there, right. SQL 1, 2, 3 can express common data intensive queries, right. It can SQL 1, 2 are not suitable for recursive queries, as we know. SQL 3 we can have. And if we now like to see SQL and database management system, so there are several GIS measure like ISRI and others, which include customized relational database named called Info, which has other GIS software can interact with GMS with SQL. And many software uses SQL to manage data in the backend of the data DBMS, right. A vast majority of SQL queries are generated by other software, right. So, it is basically I have a upper layer applications and then I am basically firing those queries to generate something at the lower level at the back end to look at the databases, right. So, like we have seen some of the queries, few more queries like name and population of the cities which are where the some St. Lawrence river originates, or say a river Godavari originates or something in our context. So, I say select CI name, CI pop from city CI and country CO and river R, where R dot origin equal to CI dot name, CO dot name equal to CI dot country and name of the river and capital equal to Y. So, if the query where population of the capital city of the country where this particular river originates, right. So, I want to find that particular city which is a CI dot capital equal to that characteristics of the capital is true, and find out that the river origin is that country origin, country name, and country name also belongs to that particular city, and then your particular river name is there, and so and the capital city equal to y. See, this particular thing is something which joins multiple table, and it is basically not using any special property per se, right. I can have databases, right, a say standard database tables, and I can join these tables. Right. So, it is basically looking at the query which is looking at the multiple queries. So, in this case 3 tables are joined together at a time, reward.origin matched with the country.name, and the country name is matched with the country.name, and the order of the join is decided on the query optimizer, does not affect the result. Whether I do this one first or this one first, on which sequence, it does not affect the result, right. So, but as such I am not using per se any special property, like I am not using any geometry property and other type of things, queries which have multiple tables to join. And we can have something aggregate statistics queries, right, where the average population of a non-capital listed in the city table or something like that, right. What is the average population of the non-capital cities listed in the city table? So, I say that select average ci dot population. If I want to print the city name also, then ci dot name comma city average ci dot population from city ci, and ci dot capital property is no. So, all non-capital cities, right. Now, we can say for each continent find the average GDP. Similarly, I can have say average GDP of the things, and that CO dot continent, where country belongs to the particular continent, and then aggregate that, and as map it as a continent GDP, where and group by the country not continent. So, what we are doing, this is more of a aggregate operations, right. For every continent we are finding those represent or those embedding countries and aggregated their GDPs and finding the average out of it. So, there are examples like having clause nested queries like this. So, like for each country in which at least 2 rivers originate, find the length of the smallest river, right. So, this is little complicated queries, but nevertheless it is again solvable by our standard SQL knowledge, right. So, like origin r dot origin minimum r length as mean length, and from river group by r dot origin, and having country star greater than 1. So, what it is telling, that at least count star greater than 1. So, at least 2 river origins. So, that means it should be more than 1 river, right. Similarly, list the countries whose GDP is greater than that of say India, right. So, select say particular country dot name from the country table, where country dot GDP is greater than any select any country COI dot GDP and type of things, right. So, that means this is the syntax what I am trying to show, see that list all those countries whose GDP level is greater than that of India. So, that can be India or any other country for that matter, right. So, again what we want to insist, that here we can have, like we have seen, nested copy query, multiple table query, this cause these things are having clause and type of things, but nevertheless we are able to do with our standard database knowledge or standard database table format, or so to say non-spatial database format. We are not exploiting any database out of it, any special property out of it, but nevertheless we can able to have those queries in place. Now, extending this SQL to spatial database. So far, see these examples, I have not exploited any spatial property, right, or neither any spatial property is utilized here. So, what we are trying to did, what we did, that the tables are having as good as our normal tables of a library or bank or something, and we can use same type of SQL things to capture this table, right. So, extending SQL for spatial data. So, SQL can simple atomic data types like integer, date, string, these are the simple or standard data types, not convenience for spatial data queries where the spatial properties or spatial concepts are involved, right. Like spatial data like polygon is a complex stuff, Spatial operation like there are operation like what we have seen topological, Euclidean, directional, metric based operation. These are different spatial properties which are in place. So, SQL3 allows user defined data types and operations. So, what I require, some user defined data types need to be there. I need to define what is a polygon, I need to define what is a polyline or point, and this different type of topological relationship. So, spatial data types and operations can be added to SQL3. So, Open Geospatial standard, half a dozen spatial data types, right, several spatial operations supported by major vendors of this who are working in the spatial area, right. So, Open Geospatial standard or which are supported by OGC, Open Geospatial Consortium, and it has a different type of spatial data types which are supported, several spatial operations, and also supported by major players or the major vendors in the areas of spatial database or spatial informatics. So, addition to whatever the things is there in the SQL, it has a geometry class, what we say base class, and there are typically 4 subclasses, like one is point, one is polyline or curve, one is surface or polygon, and geometry collection. So, again we are telling that we are now we are primarily into the looking into your 2D type of surface, right, or 2-dimensional space we are talking about. So, point, polyline or curve what we say, and the surface or what we say polygon which are is there, along with there is a geometry collection, this combination of one or more of these basic geometry types. So, again if we look at the operations, all the operations apply to 4 geometry types. So, spatial operation rather 3 major categories, right. One is spatial reference. One is there are major 3 categories like application of the geometry types, another is topological relationships, and the data analysis. So, what we see that whatever operations we want to do with the spatial data, we can put this into these 3 categories, either it is working with different geometry types or something which is having a topological relationship. As if you recollect, we discussed about the topological relationships like touching, intersection, inside the things, or different type of cases what we have seen, or crossing and or not intersecting and type of things, right. And there are data analysis type, right. So, if you look at the geometry types, there is a requirement of the spatial reference system, envelope or the boundary box, export type of things where you can date. So, there are simple data types or there are boundary type of consideration, and when we have a topological relationship, as we have seen, equal, disjoint, intersect, touch, cross, within, contains, these are the different topological relationship. If we look at the data analysis type of thing, distance, buffer, union, intersection, convexal, diff, and different type of things which are more of a some of the concepts coming from the computational geometry point of view. So, which helps us in spatial data analysis. So, if we try to look at these spatial operations, in some part or other this will fall into. Now, when we talk about the spatial queries or spatial query engine or spatial SQL, they should able to serve this type of things, right. One is that data types and the corresponding operations on those data types, right. So, my SQL other in addition to that whatever we can do with the SQL should able to support this. So, spatial queries with SQL and Open Geospatial standard. So, SQL with Open Geospatial standard. So, both standards are being adopted by many so called major companies or vendors. The choice of the spatial data types and operation is similar. Syntax differs from one type of package to another, but the conceptually things remain same. So, we should have a may need to, or the programmer may need to alter the SQL OGS given in this whatever we will be discussing here on to specific products, and using OpenGeospatial standard to SQL, the special data types can be used to in DML to type columns, or in special operation can be used in the data manipulation language, etc. What we mean to say that you can use this SQL for writing or retrieving data, or for data manipulation and different type of objective. Means in other sense, it should be as versatile as our non-special SQL. Like here, now we look at some of the queries which are have some special context or some special concepts which will be there, like list name, population, area of each country listed in the country table, right. So, it is select c dot name, c dot pop, area, c dot shape as area, country C. Now, this area is need to be calculated based on the polygon of that country or the encompassing boundary of the country. So, area calculation needs to be done based on this based on the special context, like in this case a polygon, finding the area of a polygon. So, that is operations which is under the context of the special operations, right. So, the query uses special operation called area. Note that use of special operation in place of a column select clause, right. See, we are using the special operations here itself, area c dot shape, right. So, this operation is being in that select clause. So, select, if you remember, we select from the columns, right. So, I select that c dot name, c dot pop, and then area on c dot shape. C dot shape is a column, and I am calculating the area based on the shape of the things, right. So, this is one special operations. So, here list the GDP and distance of the country's capital city to the equator of all countries, right. So, something which means one the DGP and the capital city's distance from the equator, right. So, this is the way the query is, means may not make sense of the applicability, but if this is the query, right. So, two things are there, GDP, that is a non-spatial stuff, country's capital also we have used that. Now, but the making the distance from the equator requires some geometry operation or spatial operations, right. So, CO dot GDP distance point 0 to CI shape dot y, like if you see that x, if I have my xy is the latitude longitude. So, if I set that 0 and that the y value is give me the distance of the things, right. And as distance and country CO and city CI. So, what we require, country name equal to CI dot country, right, and city's country is the same, and city dot CI dot capital equal to ES. That means, the city should be capital and it belongs to that particular country, right. So, in this case what we use is a, see, first of all finding out that point and finding out the distance from the particular CI shape, right. So, that is important to see. So, this one is a spatial operations, right. So, it has to be on the spatial operations. Now, it lists that particular country, the GDP and distance from the equator, right. So, see, we are this type of queries, if you recollect, it is not possible in our standard SQL with the standard database and type of things, right. So, this is feasible with our this sort of stuff. So, we can have special operation with where clause, find the names of all countries where the neighbors of who are the neighbors of the United States in the country table, or neighbors of India on the country table. Now, there should be a definition whom you call your neighbor, right. So, for our case, if a country touches another country or the polygon touches one polygon, then they are neighbor. So, special operator touch is used where the clause to join country table with itself. This query is an example of special self join operation, right. So, it is example of a special self join operation. Like, so what we have C dot name as neighbor of USA or even any country, country dot C I equal to country dot C 2, then touch C 1 shape comma C 2 shape. So, it is a self joining on the country table and C 2 name is equal to USA, that means one of the thing is a USA, right. So, here what we try to look at, see here the touch is a topological function. So, we are exploiting touch where of the self joining, if those are touching one of the countries USA. So, then we say it is a we have a they are the neighbor. That is my definition of neighbor. I define neighbor as that one will touch another thing, right. It can be other definition of neighbor, like if I say not only touch, within this distance also is neighbor and type of thing. So, that becomes things. What we want to look at it, that we require this something a topological function which is something different from our standard way of looking at it. Special query with multiple tables, right. If I for all rivers listed in river table, find the countries through which they pass. So, what we want to look at, that for all the rivers which are listed in the river table, find the countries through which they pass, right. So, select r dot name C dot name river R and country C, and where cross r dot shape comma C dot shape equal to 1. So, very straightforward. So, we have the river name and the country name from the river table and the country table, and my this joining criteria is that river and the particular country river should cross, that means river dot shape. So, river if we consider polyline, then it is a polyline here, or if we consider again as a polygon or something. So, it is that shape it will take up, and country dot shape they should join, or they are in that crossing should have a true value or the 1 value. So, special operation cross is used to join river and country tables. This query represents a special join operation. So, this is a typical thing is a special join operation. So, we have a special join. Special query example say buffer and overflow. The Godavari can supply water to the cities which are 300 kilometer within 300 kilometer within it, right. List the cities which can use water of Godavari. Say this is my query. So, I have a river Godavari which can supply water to cities which are within the 300 kilometer. So, whenever the canal or river is there, so we find that what is means serving area, or sometimes I am not very good at hydrology or that type of stuff. So, I can say that what is its catchment area, how much it is can serve or what is the things. So, we define that it can go up to 300 kilometer with canals and anyway that is the thing. If it is there, then we want to list those cities which can use the water of Godavari, right. So, if C 1 dot name city C I river R, so it is overlap C 1 shape buffer R dot shape 300. So, this is another challenge equal to 1 and the river name equal to Godavari. So, you see what we are doing. So, what is our objective? I have a river and I have different cities across around the things. So, from the river I want to find out within the 300 kilometer which are the cities lying. So, what I do, I have this river and along with that I create a buffer for that river, right. So, 300 kilometer buffer. Now, this buffer is a polygon. Now, this polygon I see that if the city shapes are all points or even polygon does not matter, if it is a point then I do a overlap, and if the overlap is true or 1, then I say that particular city can be served by the Godavari river or can be can receive water from the Godavari river particular thing, right. So, so what we see that overlap C1 dot shape and buffer of this river R within the 300 kilometer and do this. So, this is again a special operation. So, again we can understand that this is not be feasible or this not be there in case of a non-special or our standard SQL type of operations. Then using special operation for aggregate query, find all countries ordered by the number of neighboring countries, right. If I want to order by the neighboring countries, the number of neighbors you are having. So, it may be ascending or descending and whatever. So, this is little bit complex. So, it is aggregating. So, I need to find how many neighbors are there and type of things. So, what we see the CO dot name and CO count CO1, that is another instance of the country of the name equal to country CO1. That means something self, what we are doing self join. Then first of all, in order to make them neighbor, so touch CO dot shape comma COI dot shape should be the touching each other and it is grouped by and that CO dot name and ordered by the count of CO1 dot name, right. So, I do a self join of the country and then see that whether they are touching each other, they are neighbors, and then try to look at their count their neighbors and try to sort them or order them according to the neighbor, right. So, by default it may be ascending. If I want the descending, then I have to specify that particular key or descend or DSC when we have the order by clause, right. So, there is another query operations in nested query, right. So, select C1 dot name R1 dot name city C1 river R1 and then so what we are doing for each river identify the closest city. So, little more complex, right. So, for each river what is the closest city, right, what is the nearest city. So, one is the distance what we have to do to either from the I have to look at the city table and the river table, the distance between C1 dot shape and river less than equal to all and the select distance C2 shape from city C2 where C1 name is not equal to C2 name, right. So, what we are trying to look at that taking another instance of the city table and try to find out that what is the distance between this river and the city. Now, the distance function calculate that a special function for calculating the distance from the river, right. So, special operation distance used in this context of a nested query. Nested special query lists the countries. So, another example lists the country with only one neighboring country. A country is a neighbor of the country if its land masses share the boundary or the land masses touches, right. So, in other sense like I can say that Bangladesh is a neighbor of India, but Sri Lanka in that sense is not a neighbor of India according to this definition, because they are land masses are not touching one another, right, or something else in some other part is not a neighbor of the country, right. So, if we even look at it that way, nevertheless, if the land masses touches, my neighbor definition is they are in the same, right. So, select from the country table CO dot name in select CO name from country CO and country CO1 again self join, touch CO shape with the CO1 shape, the two country touching each other, group by the country name and there should be having a count of 1. So, at least there are 1 it is touching the country, right. It shows a complex nested query with aggregate operations, right. Such queries can be written in two expressions, namely a view definition. So, I can keep this as a view definition, that initial thing as a view definition, that means intermediate, as you understand that the view table and the view definition in case of a standard database, same concept out here. Such queries can be written into two expressions, mainly a view definition and a query on the and querying on the view. So, I create a view and then try to query on the view. The inner query become a view and the outer query in this case become a query run on the view or the query on the view. So, I create a intermediate view and then query on the view actual things. So, that is a nested query. This type of conceptually querying view definition or view table and queries are there also in the our non-spatial database. But here what we have this type of things like topological relationship like touch, or previously there are other definitions. So, what many of you know, but those are not immediately accustomed with. So, views are like tables, represent derived data or a result of a query. So, intermediate table I can say can be used simply by complex nested queries. So, if I have a complex nested query, I can divide the, I can go on creating means views at the lower level and then query on the things like I can say create view neighbor at AS, CO name, count name as the number of neighbors, and country CO name and country CO1, CO and CO1, touch CO shape and this. So, this is view, it creates the country name, count at the major components which that the number of neighbors at the component. Now, I use this view neighbor at AS like country name and the neighbors, from the neighbor is my view table and the num neighbor equal to select max, that is we want to select that with the country having the maximum neighbors, some max neighbors from the neighbor. So, neighbor is our is the view definition. So, what we tried in the today's discussion is try to see that if the spatial query requirement or spatial SQL, we require something more or something more dealing is required in order to have this in order to serve these queries. So, what we have seen that there are different operations, spatial operations etc. These are not straightforward. I cannot have those things in our standard query base, like in this case touch. We have seen calculating distance, we have seen buffering operations and into the things. So, these are the some of the spatial operations which we require for this spatial database consideration. So, let us conclude our discussion here, and we will look at some of the more aspects of the SQL, spatial SQL or the SQL dealing with the spatial databases in our subsequent lectures. Thank you.